Artificial intelligence does not actually understand language the way humans do. Instead, AI systems rely on mathematical representations called embeddings. These embeddings allow models to process meaning by converting words and concepts into numbers. When you type a sentence into an AI system, it cannot read it as text. The system must first convert each word into a form it can compute, turning language into numerical vectors that capture relationships between words. This transformation is called embedding. Each word or token is mapped into a high-dimensional vector space, where its position represents its meaning relative to other words in the dataset. In this vector space, words with similar meanings are placed closer together, while unrelated words are positioned farther apart. This allows AI models to detect patterns based on distance and similarity. For example, the words king and queen will appear close together, while king and banana will be far apart. These relationships are not manually defined but learned from massive training data. Embeddings allow AI systems to understand context rather than just exact words. This means the model can recognize that car and vehicle are related even if the words are different. Modern AI models generate embeddings dynamically based on context. The same word can have different meanings depending on the sentence it appears in, and embeddings capture this nuance. Once the input is converted into embeddings, the neural network begins processing these vectors through multiple layers, transforming them into deeper representations. Each layer in the model adjusts the embedding slightly, refining the representation of meaning as the data flows through the network. Attention mechanisms play a key role during this process. They allow the model to focus on important words in a sentence and understand how different words relate to each other. Through attention, the model can determine which parts of a sentence are most relevant, improving its ability to capture meaning and context. As the embeddings pass through layers, they become richer and more informative, capturing relationships between words, phrases, and entire sentences. By the time the data reaches deeper layers, the embeddings represent complex semantic meaning rather than just individual words. These embeddings are the foundation of how AI systems generate responses. They allow the model to reason about meaning rather than simply matching patterns. Embeddings are also used in many other AI systems beyond language models, including recommendation systems and image recognition. In search systems, embeddings allow queries to match relevant results even when exact keywords are not present. This type of search is called semantic search. Instead of matching words, the system matches meaning using embeddings. Vector databases store embeddings and enable fast similarity search across massive datasets, making them essential for modern AI applications. When a user asks a question, the system converts the query into an embedding and searches for similar embeddings in the database. This process allows AI systems to retrieve relevant information quickly, even from large collections of documents. Embeddings also power recommendation systems by identifying similarities between users, products, or content. Streaming platforms use embeddings to recommend movies or songs based on user preferences and behavior. E-commerce platforms use embeddings to suggest products that are similar in meaning, not just in keywords. In natural language processing, embeddings enable translation, summarization, and question-answering systems. However, embeddings are not perfect. They depend heavily on the data used during training and can reflect biases present in that data. Small changes in input can sometimes lead to unexpected differences in embeddings, affecting the system's output. Engineers continuously improve embedding models to make them more accurate, efficient, and reliable for real-world use. Techniques such as fine-tuning and normalization help improve embedding quality and performance. As AI systems scale, embeddings become more powerful, enabling deeper understanding of complex data. From chatbots to search engines, embeddings are a core component of how modern AI systems function. They bridge the gap between human language and machine computation, making it possible for AI to work with meaning instead of raw text. Embeddings are the hidden layer behind AI understanding, transforming words into mathematical meaning that powers intelligent systems across the world.